Welcome to the Geometric Optics video. In this experiment, we'll be making a light ray source using your phone and a cardboard box, and using it and a prism to analyze reflection and refraction. We'll also be measuring the focal lengths of two lenses and using them to create a telescope and a microscope.
To start, cut a hole in a box. Make sure the hole is wide enough for your phone's flash. We recommend cutting the hole to the bottom edge of the box for convenience.
Next, cut a small slit on the other side of the box. Make sure you don't make the slit too wide, since the whole point is to generate a ray of light. Again, it's a good idea to cut the slit to the bottom edge of the box.
Ideally, it should look something like this.
Turn on your phone's flash and attach the phone such that the flash is going into one of the holes you cut and a ray of light is coming out the slit. It is not necessary for the ray to be coming straight out of the slit, but it is necessary that the ray is reasonably thin and doesn't diverge too much.
Place the prism on the paper and trace around it. Set up the ray box such that the ray enters and exits the prism as shown. Trace the light rays and measure the input and output angles for each interface using a protractor.
If you don't have a protractor, it is possible to use your phone to measure angles instead. Place the paper vertically against a wall. Open Firefox and start an inclination measurement. Line your phone up with one arm of the angle you're measuring and note the tilt up-down. Then line it up with the other arm. The difference between these two inclination values is your angle. Note also that you can find the angle from the normal to the input ray directly, or you can find the angle from the input ray to the surface and then subtract it from 90 degrees. It is also possible to use the tilt left-right measurement, but my phone works a lot better with the up-down. Repeat this entire process for a second angle of refraction, then turn the prism such that the ray enters at normal incidence, but not at the center. Again, trace the prism and all light paths. Next, we will measure the focal lengths of our lenses. First, we'll make some holders out of cardboard. To do this, cut a piece of cardboard. We will later attach this to a textbook, so make sure it's an appropriate length. We will cut out a notch from the end. The notch needs to be smaller than the lens, but large enough for an image to get through. Make a second holder just like the first one. Tape your lens to your holder. Make sure that the tape isn't near the center of the lens. Do the same with your other lens and holder. Using a light source that's fairly far away, for example, an overhead light directly above you, and a white piece of paper, slowly lift one of the lenses and watch the image formed on the paper. When it is in sharp focus, measure the height of the lens using a meter stick or measuring tape. Repeat this for the other lens. For each lens, use your cell phone to take a picture that includes the lens and the image it forms on the paper. Hold the shorter focal length lens to your eye. Hold the other lens farther away. Look through both lenses toward a distant object and vary the distance between the lenses. At a particular distance, you should see a clear inverted image of the object. Tape each of the lens holders to a textbook or something else relatively heavy. Make sure to keep them at the same height off the table for convenience. It is also possible to use almost any stationary object with a vertical face. Just make sure you can point your telescope towards some object that is reasonably far away. Look through the two lenses and vary the distance until the image is in focus. Measure the distance between the lenses and use your cell phone to take a picture through the telescope. Now we will make a microscope. Remove the lenses from the books. Find an object you can look at, for example the barcode on your lens packaging. Tape the shorter focal length lens near the object, noting that you will want it a little bit farther away than its own focal length. In my case, I used two textbooks as a lens stand. Hold the other lens to your eye and vary the distance between lenses. Just like before, you should be able to find a particular distance where the image is clear. Also, just like before, measure the distance between the lenses and use your cell phone to take a picture through the microscope. Thanks for watching the Geometric Optics video.